Let's take a look at problem 4.217 from the online homework. It involves linear regression. So we have two variables. Again, this is what we would call bivariate data, two variables. So we're looking for a relationship between these two variables. In this case, it's commute time, how long someone commutes, and this psychological measure called well-being index that someone invented to measure kind of, again, this idea of how people feel about their lives and where they are in terms of their health, and what we'd call that is their well-being. And so you can see we have some data, and so one way to analyze bivariate data is to graph it. And in addition to graphing, right, you would make a scatter plot in this case because it's two variables, an x and a y. And what we're assuming in this case is the explanatory variable is commute time. That will explain your well-being score, how you feel about your life. And that would be the response variable. And so we could either graph a scatter plot, right, and put those in there and see if there's a relationship. You would compute that. And so you can see I see a negative association because as the commute time increases, your well-being score decreases. So I definitely see a relationship. It's an association, and we would check to see if there's a relationship. One way to do that would be to run a regression, simple linear regression. And when you run that, again, here's your x and your y. It's going to calculate a correlation coefficient for us. As we've done this before, right? Well, we've done this before. You end up with a correlation coefficient was negative. Here's the graph again, because when you run the regression, you get it. There was the least squares line of best fit, right? And it seems to go through. And I would say there's a linear relation because we can look at that coefficient. It's very close to -1 because of that line. And then important in here is this equation that we end up with here, this least squares equation, which we then can use to make a prediction. So you can see from those values there, we can see we get this equation here. And this is your slope and y-intercept. Now to answer, so that's what you would do here. We have a least squares regression equation in line. There is a linear relationship again because of the value is very close to -1. And we can check a critical score, but it's so close to -1, we're going to assume there's a relation. So from there, we would then answer these questions. What does the slope mean? Now, this is our slope right here, right? This -0.015. It's negative again because as the commute time was increasing, your slope was decreasing. And so for every unit, and so you got to remember what a slope is. It's your change in y over change in x, going back to an algebra idea. And the y is your well-being index score. And so that's what it's saying here, is that your well-being decreases by 0.051 points on average when your commute time increases by 1 minute. So every time, because again, a slope is a rate of change, and we're talking per unit, which is per minute in this case because x is minutes. So for every increase in commute time by 1 minute, the index score falls that amount, it decreases that amount. And so that's your interpretation. Now, what is the y-intercept? A y-intercept occurs when your x value is 0. And so if x is 0 in this case, that means that your commute time is 0. And so what's happening here is for a commute time of 0 minutes, we say your index score would be predicted index score 69.018, which comes from here. And so then that's where the slope and y-intercept interpretations would come from. Now predictions, you have to use the equation. So we have to substitute into this equation. So you could use your calculator to do that. Plug 30 in for x and then calculate that. Another way would be to run the regression again. I'm going to show you what to do here. And then in this case, I'm going to put in 30 right there. It's going to make a prediction for me. So when we compute it, you will see for an x is 30, our predicted is 67.552. And that's where we would get here 67.552 5 right there. So that's what we're talking about with those values there, 67.5 or 67.6 technically if you use a calculator or if you use the exact equation. So you'd get that as your predicted score. Now suppose, here's a tougher question here. Sorry about that. Here's a tougher question right here, which is suppose Barbara has a 15-minute commute and she scores 67. Is she above or below average, right? Is she well off or is she not doing well relative to everyone else? So what we need to do is make a prediction for 15 minutes. Her score is 67.6. Let's see what the prediction would be for I apologize for that, what her prediction would be for 15 minutes, right? And so what we're going to do is we're going to edit this again. I'm going to put 15 in here, compute that, and the prediction for 15 is 68.3. That's the predicted well-being score for someone who commutes 15 minutes. And so in this case here, what we have is her score is 67.6, so she is actually doing less well, right? Her score 67.1 is actually smaller than 68.3. So on average, compared to the average value of someone who commutes 15 minutes, she's not doing as well because her score was 67.1 compared to the 68.3 that we got from the predicted score.